Hey, welcome to Chemistry with Miss E. We are going to do our last topic here in Intro to Chemistry topics, and that is identifying variables, known as the scientific method when you are looking at parts of an experiment or trying to make up an experiment, okay? These are words that you kind of do learn in middle school, but you might forget or not have had the correct understanding of them. But when you do get into chemistry in your high school science courses and beyond, it's really important that you understand what these parts of an experiment mean and how to identify them, okay? So let's start with our hypothesis. The first thing is that every time you make a hypothesis, it's an educated guess, right? And your hypothesis doesn't need to be correct. And what I mean by that is, if you already know the outcome of an experiment, then why are you doing the experiment, right? So your hypothesis should be something that could be wrong or could be true, but you have a good enough reasoning, a good enough scientific guess onto why or what's going to happen when you do said experiment. This should always be in an if, then, and because format, okay? So if I place 3 plants, in a sun, or if I place 3 plants in a window with light and 3 plants in a window with no light, then the 3 plants with the light will grow because light is a necessary part of photosynthesis, which helps plants grow, right? So if I do this, then this will happen because, all right? So if this is where your independent variable is going to go, which I'll talk about in a second, then this is going to happen, dependent variable, because, and then your reasoning, okay? And your reasoning needs to make sense. It shouldn't be because I think so, or because I've done it before, or because that just is the way it is, okay? You need to actually think beyond that and think of a good scientific reasoning on why you think that's going to happen in your experiment. The independent variable is the thing that you are changing, okay? It's a thing you are changing / testing, all right? This is very, very important. So what are you changing? So what are you actually wanting to test, okay? In my light versus no light example that I just said, it would be the light, okay? So like the amount of light is what I'm changing. That's what I'm testing. The control is what you are not changing, okay? So it's what's held constant, okay? So it's what you do not change, all right? If you notice, I said I'm going to put 3 plants in a window with shade and 3 plants in a window with light. What was the same thing between both of those criteria? 3 plants. So that would be my constant. Dependent variable. This depends on the independent variable for you to know what it is. Okay, so in other words, my dependent variable depends on the independent variable. And I also want you to think of the D, dependent, for data. Okay, there's got to be some piece of data to identify your dependent variable, okay? You can't have an experiment just based on opinions. We need numbers, we need data, we need some sort of measurement to be able to figure out, did this work or did it not work? Or was there no change at all, okay? So this is your data piece. My dependent variable for the example that I said at the beginning with 3 plants in light, 3 plants in shade, it would be maybe how high they grow, right? The height that the plants grow, all right? And conclusion, okay? Conclusion is going to be you either accept or reject your hypothesis, okay? That's always the way you go. So I accept my hypothesis because, right, the data proved that it was correct, or I reject my hypothesis because the data that I got didn't actually match what my hypothesis was, and that's okay. All right, trial, this is the amount of times that you repeat an experiment, okay? So it's repeated experiment times, right? So the amount of times that you repeat it. The more trials you do, the more valid that your results are, right? You increase the validity of your experiment results when you do more trials, okay? For example, if there's a new medicine out on the market and they just did 1 trial with 100 people and they were like, it worked, I'm not trusting that one bit, right? You need at least 10, 20, 50, 100 trials, right? Like, keep showing me that with consistent data, changing the pool, right, and keeping the experiment at the play of it, that this works, then maybe I'll consider it, right? But you need more trials, okay? If you just do 1 trial, there's so many pieces of error that could happen, okay? So let's do an example where you're given a scenario and you need to identify these things within the experiment, okay? So let's start with Little Wayne, right, has mold on his sandwich. He remembers his friend Kendrick saying that coconut juice can make mold disappear. Little Wayne then sprays coconut juice on one side of his sandwich and leaves the other half alone. After 3 days, there is still mold on both sides of the sandwich. So what would a good hypothesis be in terms of this experiment, right? So hypothesis is something that you do before you know what the results of the experiment are, but for the purpose of practicing writing a hypothesis, let's do it. So remember, you always say if, right? What's the independent variable? Well, the independent variable is what we're testing. It's what we're changing, and we are testing the coconut juice, okay? So that is our independent variable, the coconut juice, okay? That's what's changing from one side of the sandwich to the other, okay? Our control, what's the control, right? It would be the sandwich was the same, right? You could say the sandwich, okay? Like we just did half of a sandwich, and then also 3 days, right? That would also be a control, okay? The 3 days was the same for both sides, okay? Dependent variable, or the control of this one, sorry, let me specify with the sandwich. It's going to be the unsprayed, right? The unsprayed sandwich side, okay? So the side of the sandwich that did not get the coconut juice, that's our control. That allows us to actually compare, did it work or did it not work, okay? So that's the one that doesn't get the independent variable applied to it. That's your control. Dependent variable, okay? Dependent variable is what depended on the independent variable. So what depended on the coconut juice is we were seeing if it helped the mold disappear. And so the amount of mold, right? Notice how I need to say amount, because amount can give me like a number, right? It can give me a measurement behind what's actually happened. So amount of mold present, okay? That's going to be our dependent variable. So let's make our hypothesis based off of this. So if I apply, right, coconut juice, right, to a moldy sandwich, right, then the mold will disappear. Because, okay? And then whatever scientific reasoning that you have, okay? So notice, if I apply coconut juice, that's my independent variable, then the mold will disappear. The mold is our dependent variable, right? That depends on the independent variable. We want to know is if I get rid of the coconut juice, is the mold going to disappear? And then your scientific reasoning for because. Our conclusion here though, right, it says after 3 days there is still mold on both sides of the sandwich. So our conclusion would be, if I take the case of my hypothesis here, I would reject, right? I would reject that hypothesis, right? In other words, Kendrick, right, is not correct, right? At least in this sandwich example. So I would reject the hypothesis, okay? It didn't work, okay? And how many trials did we do? We just did one, so if we want to increase the validity of this, right, you would want to do more trials and make sure you're applying the same amount of coconut juice, right, different sandwiches, how much mold was there. You see the criteria, right, to get your experiment completed there. So there is our first example, okay? Let's do another one here. McDonald's believes that if they put a special salt on their fries, then more people will eat more fries. Here's the data collected from two groups. Group A is with the salt, and Group B is fries without the salt, okay? So we have 4 trials here, as it says, and then in Group A, you can see the number of fries eaten, okay? That's what both of these numbers represent. So for Group A in Trial 1, they ate 200 fries, 150 fries, 175 fries, and 150 fries. Whereas for Group B, who did not have the salt, right, without the salt, they ate 250, 275, 300, and 315. So let's go ahead and apply this stuff, and let's do our hypothesis, all right? So our hypothesis would be McDonald's believes that if they put a special salt on their fries, then more people will eat more fries. So if, right, if special salt is applied to fries, right, then more fries will be eaten, right, because, and then whatever you think because, right, because salt is favorable to the human tongue, right, or salt, people like salt on their food, okay, something along those lines, right. Independent variable, so what is changing here? What are we testing? The special salt, right, so that is our independent variable, and notice I have the special salt in my hypothesis wording after the if, so if independent variable, so if special salt, right, is applied to fries, okay, or put on fries, whatever you want to say. Okay, dependent variable is what depends on that special salt. So what data piece are we trying to figure out? We want to know if special salt makes you eat more fries. So how can you say eating more fries in a number format, right? You would say number of French fries eaten, right? Okay, number of French fries eaten. All right, the control. So what was held the same, right? What's something that was constant between the two? They both had fries, right, just in general. So they were both McDonald's fries. One had salt, one didn't have salt. Who was the control group, though, right? So what group was the control group? In other words, they did not get the independent variable applied to them. That would be group B, okay? So the control group would be group B, okay? They did not get the special salt on their fries. So the trials, there were 4 trials, not too bad, right? 4 trials, that does help the validity of the data, right? Helps us, you know, kind of, it's better than 1 trial, right? Because if we were just comparing 200 to 250, that's pretty close, right? And even better so, I tell students, when you have multiple trial and multiple data sets, get an average, okay? Because I can't just compare trial 2 to trial 4, right? I need to get an average of these, and then I can really hone in on proving with data if this special salt works or not, right? But just by visuals, I can see these are all in the 200s and 300s, which is definitely higher than group A. So my conclusion would be that since group B, who did not have the salt, they ate more fries, then the conclusion would be that I would reject this hypothesis, right? McDonald's is not correct. McDonald's believed that if they put a special salt on their fries, then more people would eat more fries, but that's not what happened. So the conclusion here would be reject hypothesis. Right? And whenever you're discussing the rejection or exception of a hypothesis, discuss your data, right? You would say that group B, right, ate more fries, right? And they did not have the special salt. And you could even go into average. So like you could say on average, right, they ate, and let's, you know, do an average here real quick, which a good time to review how to do average, right? You're going to add up this data set, so I'm going to do 200 plus 150 plus 175 plus 150, and then I'm going to divide it by the amount of data pieces that I just put in, 1, 2, 3, 4. All right, and I get an average of 168.75, so 168.75. If I do that for group B, 250 plus 275 plus 300 plus 315, I get 1,140, divided by 4, hold on. Like, that's a lot of fries. Okay, divided by 4, we get 285 as my average, okay? So you could say, even on average, right, they ate 285 minus 169 rounded, 116 more fries, right? 116 more fries. All right, there we go. All right, so there is 2 examples and some definitions and reasonings behind parts of an experiment in identifying variables and the scientific method. See you on the next one.